A lot of times is that students tend to go way too fast when they're starting out working with proofs. By starting with the algebra, by starting with stuff that you guys know how to work with, by using that and using reasons that you understand, reasons that you know what they are, you start to get in the mindset of how does a proof progression work? What I mean by progression here is, how do you start something? What is quite literally the first thing you do for a proof? Because once we get over that hurdle, everything else is easy. And then it is a matter of how do you constantly use your sequence of events to show something. Think about, how would you tell somebody to make a sandwich?
Bread first.
Where?
Wait.
Well, here's the thing. And that's the idea. You have to be so unbelievably specific for somebody if they don't know where anything is in your house. If you have to, show them where the silverware is, where are the plates, where is this, where is that, where's the lunch meat, where's the peanut butter, where's the jelly, all that kind of stuff. Yeah,
what kind of sandwich are you making?
And that's the other thing, you can get into stuff like that. Guys,
because we can make millions of different kinds of sandwiches.
I agree with you on that one. But are we okay here, guys?
Yeah.
Come on. Enough. Come on. What I'm getting at here is the idea of how we put a string of logical thought together is very difficult for many students to get a grasp of. What I have found in the past few years of working through this section is that it helps out tremendously, because we all know how to solve the equation 2x minus 1 is 7. What's the first thing you do?
Plus 1 on each side.
You add 1 to each side. Can you hold on a second, please? We add 1 to both sides of the equation. We add 1 to both sides of the equation. After we did that, we simplified. After you did that, you divided by 2.
Divided by 2 on each side.
And then you x
goes to 4.
Now, what I want you to think of is that, yes, there are many ways to set up this problem. There are many ways to go through it. Some of you guys might even be able to say, hey, I know x is going to equal 4, because you can kind of figure it out real quick. But when you're putting stuff together in terms of a proof, you have to give, reasons for what you do. Okay? So this is why we use these, what's called a 2-column T-chart. This is a T-chart you're going to see a lot of over the course of the next couple of months. One side is for statements. The other side is for reasons. And the idea here is, on this side is always what you are doing, and the other side is why. Is why you did it. Okay? What you're doing and why you did it. So if I think about going back to the idea of our 2x minus 1 equals 7. Well, statement and reason. Why did I write this down here? That's the statement. But so I'm doing this problem, but why did I write it down?
It's part of the steps. You have to show what you're doing.
You're on the right track. Whiskey, do you have an idea?
It's to help you keep track of what you're doing and not make as many mistakes as you do.
What was that? Right. I just wrote down the problem. Why do you think I wrote down this problem?
Not to make as many mistakes.
Well, it's actually even easier than that, because the first step is to write down what you're doing, because you were given the problem to start with. Okay? So Merry Christmas, I gave you something. Oh, oh, oh. All right? You were given a problem to start with.
What about Kwanzaa?
Let's go with inner monologue again, okay? So the idea here is that we have to start with something. 99% of the time, the very first step on every single proof is always going to be write down your initial given statement. You were given this algebra problem to do. Make sense? You were given the algebra statement to do. So if I go back to here, move this all down just a little bit. If this was my statement and reason, is everybody okay with using S and R? I'm probably never going to write out the word statement and reason ever again. Just go back to your video game. So this one was given. Step one. Why did we add one to both sides? Do you know what that, remember these properties have been balanced? Keeping it balanced. Now, here's the thing. As we get into this algebra stuff, you guys know how to solve the algebra. It's a matter of what are the actual properties that you're using. And what we do here is we come up with this, what we call a reason bank. This reason bank are all the reasons that you're allowed to use, which means you can't make up stuff. Okay? You can't make stuff up. Also, this is something you don't ever want to lose. Ever.
No.
Yes, sir. Yes, sir.
Good question. With this,
You're going to use it more first semester than anything, and it's probably just something through chapter 4.
we'll prepare in second semester.
We don't do any first semester. So here's what I want to look at here. In this property sheet, and we'll come back to this here in a second. In this property sheet, we have all the different types of algebraic properties that we use. We have the addition property, subtraction property, and so on and so on. Now, what I want to do is I want you guys to think about when you are adding something to both sides of an equation. Just like Mr. Williams said, he said he had to do that because it kept it balanced. So whenever you add something to both sides of the equation, your reason is the addition property. Okay? Because it's staying equal on both sides. Now, Mrs. Storer, should we just say addition property this year, or should we still say add prop equal? Addition property.
Would you like to abbreviate, Mr.?
I do like to abbreviate, but should we just say, are we okay with just add prop, or should we put the equal in there?
Because then we're going to have properties of congruence? Is that what you're thinking?
Yeah. Because we're even equal on both sides, should we still keep the equal there, or should
Then
we?
I think so, yeah.
So here's what happens. What I want to show you guys is within these properties, and we're going to talk about the rest of these throughout the day today, there are going to be specific ways that you are going to be allowed to abbreviate. The ways that I'm going to show you today are the only way you can abbreviate, which means write down the abbreviations on the sheet, because it's there in front of you. I'm not taking it away from you. The idea for most of these property things is that as we start off with these for quizzes and tests and stuff, especially this first bunch of algebra problems, within the first day, you're going to be pretty reliant upon what the properties are. Yes, sir. After today, probably into tomorrow, most of you guys are going to be, okay, I subtracted on both sides equal, subtraction, property, equality, and you knew that without having to go back to your sheet. What's going to be a little bit more important is if you look on the back side of it, we start talking about definitions, postulates, theorems, things like that. That's when we start to get into stuff for next week. Next week, we'll start talking about how do I use an angle bisector? What would I do in terms of some sort of a geometric proof to utilize that? And that's where the proof progression sheets that I have, which we'll create next week, come into play. So that when we start with a problem that says ray AB is the angle bisector of angle CAD, you then would know that, oh, a ray divides an angle into two angles that are congruent. Therefore, there's something you can say about it, because it tells you this. We can relate this to what we call a progression sheet next week. We're going to come up with all these different things. We're going to have diagrams. We're going to have pictures. We'll have diagrams. We're going to have all this stuff, all this bits of information for you guys, so that way when you do get a proof to work with, you don't just sit there and stare at it and say, I don't know what to do. Because there's no reason for you to ever say that, because you have everything in front of you. Okay? The idea that you don't have something or you don't know what to do doesn't fly, because you will have something in front of you to help you. It's a matter of becoming resourceful enough to use it. And that's what we try to do in this class. Give you enough information, give you all the stuff in front of you, so that way you can go through the minutia of everything and figure out what's important. And that's what we do. Okay? So, addition property. Basically that's saying that is if you add the same thing to both sides of the equation, it's still balanced. And we know that because you guys have been working with equations since what? Second, third grade? You know? I mean, I know in second grade they do a lot of, 3 plus what is 7. Because my son's doing that right now, so I know that's what you guys see. It's the idea that you've done that forever. So whenever you're using this addition property, when you're adding something to both sides of the equation, what I abbreviated would be this. Add, prop, equal. So if you're going to add something to both sides of an equation, like we did here, notice how we wrote the next step of adding 1 to both sides? That was our second step. The reason that I would write that would be add prop equal. That's why we did that. You okay with that? Now, after we did that, what did we do next? We rewrote it again, correct. We wrote it as 2x equals 8. Because what did we do here? 7 plus 1, we simplified it. We did the addition portion, and now we simplified it. You okay with that? What was the next step that we did? We divided. We divided by 2. That was our fourth step. And what do you think? Did we divide on both sides of an equal sign? So what do you think? What property do you think we used? So let's do this. Division property equal. Division, I'm okay using that division symbol because it's the only one that looks like it. All right? I won't use that for addition. I won't use that for subtraction. I won't use one for multiplication because of the, x can be a variable. But that division symbol, it's the only thing that looks like it. All right? So that's about the only time I will write that out. Is that okay? So we divided the same thing on both sides with an equal sign. Again, this is a two-step equation that we're breaking down into multiple steps to show the properties that make this work. And we got this. Can't even spell. And now, what was our answer? So, are we done? So what do you think I should write? You're overthinking.
Answer.
No, not even that. Not even that. Done. Yeah. How about solve? Makes sense, right? Solve the equation. We solve the equation. Now, one thing let's go back and write out the rest of our little what do you want to call it, abbreviations real fast, and then I'm going to add a couple of things, little tips to put on here as well that aren't on there. Like, when do you write simplified versus when you write solve? Pretty simple things that you would kind of forget about if you're not careful. What do you think we should abbreviate subtraction properly like?
For the subtraction sign.
No, I don't want to use the subtraction sign. I don't want to use just sub because that could be substitution. What I'll do is this. Yeah, exactly. Sub T for subtraction. Property equal. You're subtracting the same thing on both sides of the equal sign. What do you think multiplication will look like? Yeah. Do I have to put the I? Is both okay?
No.
Distributive property. Dist, though, we've been using DIST for distance sometimes. How about we wrote disto for distribution? Distro? Like dist. Well, dist is okay. I think dist will be fine. I just want the division symbol. Is it a name?
What?
The division symbol? Is there a name for that?
Symbol.
Yeah. And then substitution. Substitution, what's sub S? Is that okay? For substitution?
So.
Oh, thank you. Actually, let's just do this. I want to just use substitute because it's a definitive way of saying something. Because there's a reason why we want to use substitute versus later transitive. All right. Let's see here.
Are you going to tell us about simplify and solve?
Yeah. Simplify and solve. Can I go to a clean sheet to show you the difference there real quick? Maybe on here, maybe on the bottom. When to simplify, when to write simplify, when to write solve. If we look at in here, why did I use simplify versus solve? It's a pretty easy way to think if you think of it. Yeah.
I feel like if it's solved, it would just be like the last thing when you're done.
Yeah, and that's kind of where I'm getting at. Solved is when you're done. You've solved for X. Simplify is when you're doing the process in the middle. Simplify is for when are in the middle. It's for when you rewrite. Solved when you're done. When X equals something.
So would we use simplify if we're combining like terms?
Yes. Yep.
So doing any kind of math?
And any kind of math in the middle, after you've done an addition property, a multiplication property, a division property, any of those properties of equality, as soon as you rewrite a problem, whether it's distributed property or whatever, once you rewrite a problem, you simplify. Does that make sense? It's probably stuff that you've done, you just never thought that that's what all of these little bits and pieces mean. Okay? The rest of these things on here kind of come up, they don't come up as much as what we need. Now, reflexive property, symmetric property, transitive property, things like that. I'm not going to really worry so much about that yet today, at all, between today and tomorrow. A lot of that stuff's going to come up into play when we start looking at segments and when we look at angles. Now remember, segment stuff and angle stuff are really the exact same thing, just some are segments and some are angles. That's it. There's no real difference here. So let's look at an example of another one for an equation. Why is it? It's never really worked right. Oops. Oh.
Oh no. Mr.
Screwed
Murphy
everything
will
up.
have to work his right. And Mr. Murphy,
Yes, sir.
you want help with your smart board?
No thanks, but I appreciate the offer.
Are you sure?
Let's solve another one.
I'm not.
Now, the other thing that works out nicely with proof stuff is that there are so many different ways to start a problem. It is completely and totally up to each and every one of you guys to decide how you want to start. Because is there always going to be a one-size-fits-all to start a problem?
No.
Not necessarily, especially with the algebra. When we get into the geometry stuff, there will be a specific starting point. What I mean by that is, when we start looking at geometry stuff, you're going to be given some specific geometry term to use, which means you start with that term. You start with that definition. You start with that theorem, something along those lines. And then we work our way out of it. So we wrote down the problem, 2x plus 5 equals 20 minus 3x. What's my reason?
Plus 3x on this.
Oh, what's my reason? Given. Given. So my first step was to write the problem down. Why'd you write it down? Because I gave you the problem to do. It's like the gift that keeps on giving. Yeah. Don't even remind me of that. I swear my children wear 15 outfits a day. Now, what do we do next? Add prop. Add prop. Remember, say it's add prop equal. Okay. So what did you add to both sides? Yeah, perfect. We're going to add 3x to both sides. So my second step is to add 3x. And the reason you said was add prop equal? Perfect.
And then step 3 is subtract
Whoa,
prop.
whoa, 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 whoa. Step 3 is,
Simplify.
very good, rewrite. In other words, simplify. Simplify, simplify.
Oh, this is so hard. I used to be able just to solve it.
Okay?
Actually, it is pretty.
When you rewrite the problem, that's when you're simplifying. Now what are you going to do? Subtracting 5. Good. So notice how it's forcing, what this stuff does is that it's forcing you to show all of your work. We subtracted the same thing on both sides of an equal sign. What do you write?
5.
Yep. Subtraction, property.
Then simplify.
What was that, Whiskey?
Simplify.
Very good, my friend, very good. Another thing to remind you guys is that there is really no set number of steps for a lot of these. Okay? There really isn't.
Divided by 5.
What is good? Perfect. And it's solved because x is, yes sir,
So I subtracted 2 from each side, but I got the same answer.
that's fine. And what happens is, as long as your properties work out, because then you did subtraction property of equality, then you simplified, and then you probably subtracted 20 going the other direction, so it's another subtraction property. Then you still had to divide. That's the thing about algebra, is that you can still get the same answer going a couple of different ways. As long as your properties line up, that's fine. Okay? There are many, and that's the whole thing about proof, is that some people take a different route to get there, but if the logic is correct, it's not wrong, if that makes any sense. But yeah, that's fine, that's fine. And then we know x is equal to 3 because we are solved, done. Isn't it QED when you're done? Isn't that stand for something like?
It's Latin. Oh, I
It's-
should know this.
Quantum dominium. I just made all of that
It's
up.
actually, no, it's in the geometry.
It is?
Yeah, I'll find it, go ahead.
Because I remember in college we had to do a lot of proof stuff, like awful proof stuff, like full walls of. You guys have all seen Good Will Hunting, right?
The student classical teachers.
I have.
Okay. You have a homework assignment for the weekend. You have to watch Good Will Hunting.
Are you gonna be graded on?
It's worth a watch.
It's a great movie.
Wait, watch what?
What is that?
Will Hunting. It's about a kid who is a mathematical genius who doesn't want to show that he's smart because he doesn't want to lose his friends. It's when Matt Damon and Ben Affleck actually wrote the movie, and they wrote the whole thing about it. They won Oscars for it. Robin Williams is a psychiatrist in it.
It actually looks cool.
Anyway, you have homework.
Okay.
It's a great movie. It really is.
It's worth a watch.
Yeah,
What'd you just say?
Someone.
okay, let's try another one.
Is this something good about yourself?
Do you want to try and do this one on your own?
No.
Try it.
Alright, try it. Oh, that's easy. That's distributed all the way.
I'll even give you a hint on the first one.
No.
Oh, wow.
Really?
Yeah,
Ooh,
man. That's a really good.
Hey, I try to help. Just trying to help, man. Just trying to help. Why don't you guys take a couple minutes and see if you can figure this out? Now, again, there's going to be a couple of different ways that you can go about doing this. See what you can come up with. You got to write out the whole thing. You can't just write down the answer.
I'm done. I quit already. See.
It was like.
Better not bring myself in the house. Say that good. Uh-huh.
Yes, ma'am. Alrighty, what do you got?
No, it is.
Okay. Try to not show it all at okay, that's fine. Now, did you do the same thing on both sides of the equal sign? So if you do that, I'm okay.
No, I said the Colts are gonna win. That was a good.
That's okay. That's good. I like that.
God, he said the code.
Yeah,
Wait.
that was the bet.
And he wrote reason, just. Because you're doing the stuff through there. Yes, sir.
That's 240 on my
Lose all that.
bet.
Did you, and this is the second one on here, is this? Exactly, is
I don't
this?
have money to bet with.
Yeah.
Okay, that's
You're not doing it both sides?
129 days from now. 128, because yesterday is 129.
There's
said
no
they gonna win
equal
this
quality.
They're not gonna win. They're gonna struggle to make the playoffs.
Hey guys, real fast. I've seen this, actually the three people so far accidentally did this for distributed, bless you, distributive property. The distributive property is just on one side of an equal sign. It does not go to both sides. It is not distributive property of equality. There's no equal symbol in distributive property. If you have that accidentally written on your reason bank, please cross off the equal sign real quick, okay? There is no such thing as distributive property of equality. Okay, there's no such thing. What's that? There's multiplication property of equality, yeah.
Oh, I use that.
Oh, for doing this? Multiplication property of equality, that means you're multiplying something on both sides. This property is distributing. All right? So if I go through here and you do your distributive property, you get negative 44x minus 8 is 80, and this is our distributive property. Oops. Or did I, what did I abbreviate distribute? This problem, okay. Okay. Now at this point, I'm going to add 8. Simplify. And then the next one was divide by -44. I went over the equality sign, so it's division, property, equal. And then I'm solved. Okay. Now, there are other ways of going about doing this. Okay. Did anybody divide by -4 to start? No. You could have. Good. So, what I want you guys to work on tonight, we're going to give you 5 of these. Okay. Just 5 of these for this evening. Shh. Ladies and gentlemen, come on. This is section 2.5. The problems around the book on page 109.
That was the weirdest sneeze I've ever heard in my life.
I'd like you to do numbers 6 through 14 even. Just 5 of these. Write them out in that 2-column style. You want to show all of the work. We can't skip steps on proof stuff. That's the one thing that you have to force yourself not to do. You have to show each step you're doing. You have to designate what you're showing and why you're doing it in order for it to be a valid argument. Okay? We'll do a little bit more of this stuff tomorrow.
I bet.
And go from there.
140 on the Super Bowl already. I'm gonna bet some more too. If anybody wants to keep betting, I'm gonna keep betting. You guys are gonna be like, what? Caleb, bet. Caleb,